I'm originally a chemical engineer, and when I finished my undergraduate degree, I started to work for Environment Canada in a research lab, and it was quite an important time for the development of waste management, because it was the start of the Basel Convention for on transboundary movement of hazardous wastes, and also a lot of waste management legislation in Canada and the US. And at that time, when I was doing research, it was mostly about understanding the impacts of waste in the environment and development of treatment technologies. And over time, I think what has happened is that we've realized that the impacts of waste are not just the things that happen to waste in the environment, but also the fact that we're squandering valuable resources. And that's really what a circular economy is all about, is doing both of those things, trying to prevent the impacts of waste on the environment and making the most of the valuable resources that we extract from the earth.
One of the successful things is it's all about underpinning and looking at the barriers for the implementation of circular economy in the MCM, mineral construction sector. And that was through that to try to understand the current practice and then looking at different barriers, and then coming up with enablers, solutions to try to address some of these barriers. But most importantly, it looked about collaboration between the academic field and supported by our industry partners to address some of these challenges through various activities, which included workshops and co-creating the solution together. And that, for me, that was the key for the success of this, is the co-creation, working with the industry partners to develop viable and feasible solutions.
I think if you take material from the soil, if you produce objects, you're taking things out of the environment. You'd better put them back. They're not there forever. You know, and it's a very difficult idea to get across because people don't see the built environment as temporary. But what this, the center has been doing is great, because they do look farther into the future. A lot of work has been done on recycling, and on eliminating eliminating production in which too much carbon is released into the atmosphere. I mean, I think it's been fantastic.
The circular economy and the pathway to decarbonization are intrinsically linked. Around 50% of all emissions come from the way we use, extract, refine the resources we use as a society. And therefore, if we want to tackle climate change, if we want to meet our net zero target, we need to pay attention to the way we are transforming those resources. The Construction Minerals Center has been crucial in trying to open in innovation spaces, trying to open up and designing pathways for implementation of circular economy strategies.
I think it'd be fair to say that we're making progress in particularly highlighting the issue of the need for soil reuse on construction sites, and working with a variety of different stakeholders to try and get that to happen. So, for example, we've been working with Cornwall and Lancaster City Councils to look at how they can incorporate the circular use of soil into their planning policies, which then influence constructors and hopefully we end up with more sustainable and circular use of soil.
So a lot of our work at BGS is really focused around the use of minerals sustainably, reducing the environmental impact of mineral extraction, and also to sort of reducing the overall impact of minerals in total, which of course often means using less or using alternatives. This seemed like a really natural fit to the centre. So when it was being put together, sort of questions around circular economy and raw materials, especially around construction minerals and aggregates, that was something that we at the BGS were really interested in, and we thought we had good technical knowledge and expertise, especially around the kind of mining and quarrying, that would link really well with some of the kind of academic work around mineral flow analysis, market analysis. So we thought we had a really good fit and could really amplify our work and contribute to the centre's work by kind of combining these different technical specialisms.
The work that we're doing as part of the Circular Economy Centres and through using Bayesian MFA is really important to better understand how we use materials in the economy. And this is important so that we can design policy measures or technologies that are actually effective at reducing environmental impact, and also for making materials that we need more available. So an example is if we apply Bayesian material flow analysis to better quantify how we use critical minerals in the economy. This can then help with better securing their supply, because at the moment their trading and how they're produced, used and disposed is not very clear, and that's a key example. And another key example is that we can effectively design policy to reduce environmental impacts, and we can do this in a targeted and effective way if we have the baseline information, which is provided by Bayesian material flow analysis, about how those materials are used in the economy.
I think in terms of the impact that the centre will have on policy in the future, the biggest thing that they have done is unlock some of the questions that have been unanswered for so long. So how do we improve design principles to reduce the amount of waste that is designed in buildings across the UK? How do we take waste products and use them to build new materials? How do we reduce the reliance that we've got on imported construction materials into the UK? How do we transform the industry? How do we do this in a safe way? These are all massive questions which have been unanswered for quite some time, and the research that the centre's produced is answering those kind of bottleneck questions and saying, well, actually, here are some design principles that we can use to design our waste. Here's how you can use waste products to build new types of cement, and here's how it can happen safely. So these questions that policymakers have struggled with for some time, the centre's answered, and not just through academic research, through publishing tools or things which look specifically at understanding where materials are in the UK, understanding life cycle analysis better. It's actually given practical things that policymakers and industry can use to help deliver the transition and lead into the sector.
So how does this impact on the future? Well, the researchers who have developed this interdisciplinarity and these interdisciplinary skills have got the ear of government. They speaking to industry such that industry understands the need for circularity. Furthermore, moving forward, there is this incredibly strong network of researchers, a large number of whom have gone into academic positions because universities recognise the incredible need, or the really strong need, for these skills to be passed on to the next generation. And this network of researchers will go through their careers knowing who the other experts are in the field, because they've collaborated with them already, to further build this network and almost a snowballing effect of keeping this research going and the legacy going forward.